We're going to be looking at example 2, parts A and C in your section 4.2 notes. Here we're going to see if the mean value theorem applies. These are the two conditions we need to see if the mean value theorem applies. That's continuous on the closed interval and differentiable in the open interval. If we know those two conditions are satisfied, then we're guaranteed to find a point x in the open interval where the derivative of x, or the slope of the tangent line, is equal to the slope of the secant line. Okay, so we're going to start with part A. We have the natural log function of 2x, and the natural log function is definitely continuous for its domain. So we know that our function is continuous on the interval 1 to e. Okay. All right, so we know also that this function is going to hopefully be differentiable on the interval 1 to e. We can go ahead and look at the derivative to check. Okay, so the derivative of the natural log function, we put the denominator as the inside, so 2x, and the derivative of the denominator goes on top. Okay, so 2's will cancel and we'll get a derivative of 1 over x. Okay, so the only bad spot here is 0. 0 is not in this interval, so we do know that f is differentiable on the open interval from 1 to e. Okay, so we have the two conditions of the mean value theorem that are satisfied. We also have the derivative of the function at x here. So now we want to set the derivative equal to the slope of the secant line. So let's go ahead and find the slope of the secant line. So we're going to be taking f of e minus f of 1 all over e minus 1. Okay. All right. So setting these two equal to each other, we're going to have 1 over x equal to, well, f of e. If we go back and plug in e to our function, we're going to have the natural log of 2e. Okay, then minus, we'll go ahead and plug in 1 to this function. We're going to have the natural log of 2 all over e minus 1. Okay, so right here, this is the product rule for logs. So a multiplication can change into an addition. So we have 1 over x equal to the natural log of 2 plus the natural log of e, using that product rule, minus the natural log of 2 all over e minus 1. That's really good news for us because these natural logs of 2's are going to cancel out. We also know that the natural log and e cancel each other out, so we get an answer of 1 for that part right there. All right, so this makes things a lot easier. We can go ahead and cross multiply to get rid of the fractions. 1 times e minus 1 is just going to leave us with e minus 1. This side we have 1 times x, and that does it. That's the x value that we're looking for in this interval from 1 to e. E minus 1 is in this interval. You can estimate it if you would like to. Okay. So if you go ahead and pull out your calculator, let's look and see what that might be, just as a double check. All right, so E button is above the log. All right, and then I just want E minus 1, so that's approximately 1.72. Okay. All right, so, and that is in the interval, E is around 2.7. Okay, and that completes part A. Okay, so for part C, okay, so the issue here that's not going to make our function continuous is the denominator. Okay, x can't be -2. That's going to be where the vertical asymptote is, or the break in the graph. Luckily, that is not in the interval that they're asking us about. So f is going to be continuous on the closed interval from -1 to 2. Okay, so we're also going to see that f is going to be differentiable on the open interval -1 to 2 because of this being outside of our derivative. Okay, so speaking of derivative, we need to use the quotient rule here to find the derivative. So we will square that denominator. Okay, we'll go ahead and write the denominator upstairs. When we take the derivative of x, we're just going to get 1. Okay, now we're going to leave the top x alone. The derivative of x plus 2 is 1. Okay, so working this out, we're going to get the x canceling with a negative x. So we're just going to end up having 2 all over x plus 2 quantity squared. Okay, so definitely we can verify that this is differentiable. The same issue of -2 does not occur in this interval. Okay, now we need to look at the slope of the secant line. So we're going to be looking at f of 2 minus f of -1 all over 2 minus is going to end up being a positive 1. Okay, so we're going to get 3 for our downstairs value. Okay, f of 2, plugging it in here, we're going to get 2 over 2 plus 2. That's going to give us a 4, which we could reduce to 1/2 if you would like. Okay, and then we're going to have minus. Okay, we're going to plug in a -1 all over -1 plus 2. It's going to be 1 there. Okay, so we definitely got a little bit of simplification to do. Okay. So we have 1/2 reducing here, minus is going to be a +1 all over 3. Okay, 1 plus 1/2 is 1.5, or we can write that as 3/2 all over 3. Okay, maybe it's better to go over here and write this as a division problem. So we're taking 3/2 divided by 3. Okay, writing it that way kind of helps us see how to simplify. So we're going to be multiplying by the reciprocal. Okay, so we're going to have 3/2 times 1/3. Okay, so those are going to end up canceling, and we're going to see that the slope of the secant line is 1/2. Okay, all right, so remember where we're going with this. We want to set the derivative equal to the slope of the secant line. So we have our derivative and we have our slope of the secant line. So we're going to set those two expressions equal to each other. Okay, so I'm going to have 2 all over the quantity 2 plus x squared equal to 1/2. Okay, so if I go ahead and cross multiply here, I'm going to get 2 plus x, that quantity squared, is equal to 4. Okay, I want to take the square root of both sides. So I'm going to get 2 plus x. Okay, make sure here you do plus and minus when you take the square root of 4. So I'm going to get x is equal to, if I move this over, I'm going to get -2 plus or minus 2. So I'll get 2 potential values. So -2 plus 2, I get the value of 0. And then -2 minus 2, I get -4. Okay, now I need to make sure that those are both okay. So remember, I'm looking for answers in the open interval from -1 to 2. So I see that I'm going to have to go ahead and throw that -4 out. It's not in the interval. However, 0 is, so that's the one that we'll keep as an answer.